Hello students, welcome back. So here we will be discussing about the different components of a computer system. It is already discussed in the last videos. Still this slide is there, so I am going to discuss. So this is the CPU, this is the memory, this is input output devices. A computer system actually this is the environment of computer system. So these are the basic components. Without this we cannot call a system a computer. CPU, central processing unit, which processes information, and information will be stored in the memory, and information will come to CPU and it will be processed. So CPU is like our brain. The human being has brain. So in the brain we process information, we recall something, we do calculations, we take decisions. So all these things will be done in the CPU, and in the memory the information will be stored. Another thing will be stored, that is called program or code. What logic you want to run on this CPU, like what problem you want to solve, that problem has to be solved in terms of programming, already discussed in the last video. So that programming will be done, or coding will be written, or kind of like a solution will be prepared, and that solution, list of instructions to prepare a solution, will be prepared and will be stored in the memory, and those instructions will go one by one to CPU, and CPU will process that information and will create new information and will be stored again in the memory, and we can display it here in the output device, or we can take any input during the execution. We can take any input which will go to the memory, and again CPU will get that information. So this way actually a computer system runs. Again I am saying this is already discussed, but it's a very clean diagram. With that it's very easy to make you understand that memory will hold the information and coding. We call software, apps, application, programs, whatever you call, that piece will be stored here. So that's why in the computer memory is required. So memory is for storing information and code, and CPU is for eating those information. It will grab that information from the memory, it will process that information, means it will do the thing which is written in the information. Like if I ask you to give me a glass of water, so this is the instruction, so you will perform that task. So how to perform that task? It is already defined inside your brain. Like that, the CPU is already defined with so many instructions it can perform. If you ask anything to do, the CPU can perform that, because CPU is built like that. So if you have curiosity to understand how CPU works, how they are built, you can go to YouTube and you can search the making from the CPU and the evolution of CPU. All these things you will get. So we'll be also discussing about it in the subsequent videos. So this is very important thing to discuss. So in the next video we'll be discussing other things. I am taking this video which already I have made and uploaded in the Learn Digital channel of mine. I've just picked this video. I'm going through the diagrams and I'm trying to discuss those things, because it is important. Well, this is what I'm here also I'm discussing. Memory stores instructions and data. So already I discussed. So when we have a slide, when we have a reference, it is better to make somebody understand. So this will be the process. Here we will be having slides or information here in the see, as I said, you can see this a equal to 2, b equal to 5. These are the values 2 and 5 we have to add. 2 and 5, a, b. The value of a is 2, value of b is 5. These are summed up, and this is the result is stored in another variable. We call it variable. We'll come to this when we'll learn programming, and we display. So what these three lines represents? It's instruction 1, instruction 2, instruction 3, instruction 4. This is another instruction 5. Suppose 5, 6 instructions are required to sum up two integer or two values, numbers, and to do it you have to write this program. This program will be stored here in the memory, and one by one instruction will go to CPU, and CPU will process the instruction. Again it will go to the next instruction, it will process. Again it will get to the next instruction, it will process. We will discuss CPU, the architecture, what are the different components of CPU, we will understand better. So up to this is the discussion what I already discussed. You can see very beautiful diagram. I made this video very long time ago, and is very nicely represented here. So see the memory, CPU, result is coming to the output device. So here let me go to this. Yes, so what is computer is already discussed. Okay, so computer, software and hardware is a combination of software and hardware. Electronic components are called hardware, and software, the programs, instructions written and stored in the memory, we call software. So these are the different softwares we have. Out of these softwares, already discussed that different types of softwares. Windows is a kind of system software, and all the other softwares here you see, these are system application softwares. Why we call application softwares? Because they are made for specific purposes. Like see, the Facebook app is for Facebook, WhatsApp is for WhatsApp, YouTube you can see the game, this game is for in a particular kind of game. All the games will not be there inside this single game. There is a music media player software, VLC, browser. So different purpose, different softwares, we call those softwares application softwares or apps. And this is a kind of general purpose software which actually manages the hardware. This is called operating system. So one example of system software is the operating system. So I'm writing so many things here, and in the background actually I'm discussing, so I don't need to bring the sound here because I'm actually discussing. See, layer diagram was discussed earlier here on the board, whiteboard. So see, a very beautiful diagram you can see. These are the different application softwares. Windows, the operating system which will manage the hardware. See, user cannot directly go to the hardware and make the things work. It cannot send its 2 plus 3 to this. It has to go through some layers. So this user, this section will give instruction to the application, and application layer will communicate with the operating system, and it will give the instruction to the hardware, and hardware will perform that task 2 plus 3, whatever. All the things are going on like that. So this diagram you remember or you note down, a very beautifully prepared slide. So things actually is useful. Once you prepare something, it will always be useful. So this way our lecture is actually completed. So another, as I said, programming, we'll start programming. And when we start programming, we'll discuss about this thing, compiler, which is a part of system software. Now I'm not going to that, because when we start C programming, we will discuss about compiler and C programming together. So very nicely prepared slide. So here I've already started discussing in this slide, but now I'll not continue. From here